Hey everyone, in this part of the lesson on antiderivative rules, indefinite and definite integrals. In order for us to find indefinite and definite integrals, we need to familiarize ourselves with antiderivative rules. Okay, so we want to be able to do it for all these types of functions, but in this part, we're going to focus on polynomial and radical functions. All right, to warm us up, here are some simple indefinite integrals. I'd like you to pause and try doing each one of these at this time. All right, the antiderivative of 3x squared will be x cubed. And I can test that by taking the derivative of x cubed, and that will give me 3x squared. And you always want to remember plus c. X to the fourth will be x to the fifth power, but 1/5. Now I can plus c. And I can check that by taking the derivative of x to the fifth power, or this function part right here, this antiderivative, and get x to the fourth. Okay, now so you might have started recognizing a pattern and start seeing, well, you look at the power like 99, and you go, okay, so the antiderivative must be one bigger than that, right? And then you go, okay, how do I get my number in the front, this z, to be just 1, right? Because if I take the derivative of just z to the 100, I'm going to have to multiply this by 100, right? So then you go, okay, so then I need 1 over 100 to make it balance out, where if I take the derivative of this 100 and this 1 over 100 are going to create a 1. And then you always want to remember plus c. So finally, if we were to create a rule for x to any power of n, we see that we keep the x, the base, but then we raise the power to the n plus 1, and then we need to do something here. Now here are two options. We're going to either do 1 over n x to the n plus 1, or 1 over n plus 1 to the x to the n plus 1. Okay, so I want you to pause and think about this. Which one do you think it is? Is it option A or is it option B? Okay, so the way that I might figure out which one is it is to test this answer. Okay, so what I'm going to use is I'm going to use this x to the fourth as an example, meaning n is equal to 4, right? Because that's what this fourth power represents. So we know the answer is 1/5 x to the fifth. So which one makes sense? If I try A, it would be 1/4 x to the 4 plus 1. And then B would be 1/4 plus 1 to the x to the 4 plus 1. And we see that for 1/5 x to the fifth, it makes sense that option B makes more sense. So it's this one. So in other words, the rule goes by this. It's 1 over n plus 1 to the times x to the n plus 1. And of course, we don't want to forget the plus c. And this is what we call the reverse power rule. Because do you remember when we did derivatives, we said, well, what's the derivative of x to the n? We said that that's equal to n times x to the n minus 1, right? That's the power rule. So to reverse it, we just go the opposite direction. So if we remember, what we did was we first multiplied by n. So I'll write this down. We first multiplied by n, and then number 2, we drop the power by 1. Right? This is the power rule right here. But if we want to do the antiderivative, we have to go the reverse order. So in this first power rule, we went down, right? We went 1, then 2. If we want to do the antiderivative, we have to go the other direction, meaning what needs to be first? We first need to, instead of dropping the power, we need to raise the power by 1. Hence this part right here. So raising the power by 1 is right here, raising the power by 1. And then after that, step number 2, going the opposite direction, then we need to divide by the original this higher power, right? So instead of the n minus 1, we're not multiplying by n minus 1, we're multiplying by this higher power. So we need to divide by the raised power. So that's why we dividing by the highlighter, dividing by the raised power. That's why we divide by the raised power, or multiply by 1 over n plus 1, same thing. All right, so here are some challenging indefinite integrals. So why don't you pause and try that using the reverse power rule that we just learned. All right, so here's the first one, 4x fifth plus 2 over x cubed dx. What you need to know is that this 2 over x cubed needs to be rewritten to help us do this problem better. So it'll be 4x to the fifth plus 2 times x to the negative third power, and that's the way we need to do this. Okay, now that we know that, let's apply the reverse power rule. So I see this x to the fifth power here, right? So I'll just deal with that first. It's going to be x to the sixth power, and then reciprocal of the 6, which is 1/6. And then I can just multiply by the 4 there. So in other words, this would be 4/6 x to the 6, and then it makes sense when you take the derivative of that, we'd get 4x to the fifth. Okay, the next one. So I'm going to keep the 2 aside, and then I'm just going to deal again with this x to the negative third. This, if I raise the power by 1, it's going to be x to the negative 2, and then 1 over negative 2, like that. And then we don't want to forget the plus c. Okay, so what that means, if I simplify this, this would just be 4/6 x to the 6 plus, actually not plus, it would be minus x to the negative 2 power plus c, or we can say it's 2/3 x to the 6 minus 1 over x squared plus c. Any of these would work. All right, next one, 6y 1/2 plus 2 dy. We know that this is equal to, I'll keep the 6 on the side and then just deal with the y to the 1/2 first. So it's going to be y to the 3/2 power, because if I add 1, it's going to be like adding 2 over 2. So that's why it's 3/2. And then we can just, instead of doing 1 over 3/2, I know it just means reciprocal. So it's going to be 2/3, like that. Okay. Plus, and then 2, okay, what's the original function that gives me a derivative of 2? It would be 2y, and then plus c. So that's the answer here, and you can simplify that if you'd like. All right, the last one. Okay, this looks really weird, right? The indefinite integral of just dx. Well, if there's no number there, we know that there's like a hidden 1, right? So it's just asking, what's the indefinite integral of 1 dx? And how do we get 1 as a derivative? So in other words, what's the original function? It would just be x, right? Because the derivative of x is 1, so it would be x plus c.